If we can get light from the solar system, we really would like to measure those molecules I talked about, to find out what the composition is. You know, what is it? What kind of a planet is it? And we can do that if we try to get this light and maybe do it more sensitive. We observe a spectrum from the planet, right? And the star. We see the light of both. We then observe the spectrum of just the star, because the planet is now behind the star. And we take the difference, and we subtract the two. What's left is the spectrum, or the light from the planet. So this is what we try to achieve. Now, there is currently a mission that's looking at thousands, or has already, I think, finished looking at most of the stars that may have transiting planets. And this mission was originally called Deep Impact. I don't know how many of you remember, but a few years ago there was a mission to a comet called Deep Impact, where there was a block of copper that was released into a comet to hit the comet. The comet exploded, and then the spacecraft would use instrumentation to measure what came off. And this is a way to try to understand the composition and interior of a comet. Well, that mission ended. So what do you do with the spacecraft? Well, you go to another comet, and you call that mission Dixie. But it takes many years to get to the other comet. So what do? You observe transiting planets. It's called epoch. So, and this is what, again, Drake Deming, the same fellow, was the principal investigator on this part of the mission. Micah Hearn was the principal investigator on the cometary mission. And so they went ahead and made observations. And there are no results yet on the stars. But what they could also do is look back at the Earth, because they were quite far away. And look at that. This is a view of the Earth as seen by alien eyes. So if I was an alien and I was looking through a telescope at the Earth, this is what I would see. And in fact, you can look at this and see another very interesting phenomenon, which kind of is similar to what you would see in transiting planets. And that would be this. Watch carefully. That's the moon orbiting the Earth. These curves, what they are is the energy of the total intensity that comes from at these different wavelengths from the planet, from the Earth. And you could do the spectroscopy. You could measure the molecules on the Earth. These are the Earth, water, lots of water, because we have lots of water. There's a little bit of methane, must be all the termites in cows. And then you have CO2, which actually is not so bad, but we do emit a lot of it, and the plants, of course, love it. So if you take that data and you say, well, this is what the Earth looks like, and we can't see the whole Earth, we just look at the total light in little pieces across the planet. This is what we would see. So if we were looking at a planet, extrasolar planet, we couldn't resolve it. We couldn't see details on it. All we could see was the total light. But as it rotates, as it orbits around the sun, it gives us a different face. And this different face is like a map. So here is a map of the Earth as an alien would see. You know, it kind of compares to the continent here and a lot of landmass here. It looks very, very similar. In fact, that's already been done on Extrasolar Planet. And this is the one. The planet is this one. HD 179733b. I don't know what that is. But in any way, it's a planet. They made the same kind of measurement. And here it shows that this one part of the planet is quite different than the rest of the planet. Maybe it's a continent. Who knows? But anyway, so this kind of work is just the beginning. But a lot of this will be improved significantly. It will be improved with new technology. Here's the James Webb Space Telescope. This is a 6.5 meter telescope. It's 3 times in diameter of the Hubble Space Telescope. And it focuses on the infrared region of the spectrum, which makes detection of extrasolar planets much easier, because most of the light from stars is in the visible. In the infrared, there's very little light from the well, there's less light from the stars and more light from the planet. And so you're much easier to see planets in the infrared. So this gives us hopes of finding Jupiters, at least hot Jupiters, whole Jupiters that are close, because, Earths, hot Earths, close to the star. There's a spacecraft that was launched in March. It's called Kepler. And its job is to look at over 100,000 stars and looking for transits. And its sensitivity as such is that it should be able to detect Earth-sized planets. This is a 3.5-year mission, was launched in March. In the future, we could go to an interferometer, this is many kilometers across. You have mirrors that are kilometers apart, and so it gives you the effect of a huge mirror. And the advantage here is not the collection of light, but able to resolve the distances between objects far away. So maybe you could actually see the difference spatially between the planet and the star. And also there's the Terrestrial Planetary Finder, which is another mission to do similar things. Now, we all know that the best way to find other Earths is to really go to explore them. That's really what we want to do, right? Isn't that what we want to do? Well, you know, we've always done this in history. Remember Columbus? He discovered America, right? He went where no man had gone before. At least we didn't know. Maybe the Vikings or the Chinese. But nevertheless, he was an explorer. There was Magellan. He first to circumnavigate the globe. And then there was Voyager spacecraft, actually 2 of them. They were launched in 1977. I consider that, and many of us consider that the greatest explorer of all time. It explored all the outer solar system. And currently, it exited the influence of our sun. It went outside our solar system. It's now over 100 times further away from the sun than the Earth. And it went across this bow shock, across the termination shock last year. And so now it's the first interstellar mission. And this spacecraft is going, and to give you an idea of the difficulties in communication with spacecraft in general, I have a little thing here. It says the communication to Mars. It takes 15 minutes. When I send at the speed of light, I send a signal to Mars. It takes 15 minutes to get there to the rover, for example, and then the rover sends the signal back that I received the signal. It takes 15 minutes for it to come back. So when I'm on the controls, it's like a video game, but a very, very slow video game for the controllers. And so if you want to go to Jupiter, the spacecraft to Jupiter, it takes 45 minutes one way. On Saturn to Cassini, it takes over an hour in each direction. So you send a signal, and to make those images that we saw, the round trip is like 2.5 hours. The Voyager spacecraft, it takes 16 hours for the speed of light, a radio signal to reach Voyager. It's so far away. And the nearest star, it takes 4.2 light years. 4.2 light years for light to go. And of course, driving in DC traffic can take you that long. And an interesting story on this spacecraft, Voyager spacecraft. Remember, this was 1977 when it was launched. The idea was by a scientist, the planetary scientist that many of you may know, Carl Sagan. He got together a team to basically provide some information about the Earth to whoever finds Voyager, because they knew Voyager was going to fly out of the solar system. So they designed this disk. It's like a CD. And this disk was made out of gold, and on it had information. It had first information over here, tells you how to play it. Well, these aliens better be real smart, because I had no idea what this is saying. Maybe Carl Sagan knew, but I don't. And then it had scenes of the Earth. So you could actually see images of cars, of planes, of people, of birds. You could hear sounds of the Earth, you know, birds chirping, railroad trains, all kinds of stuff. They also had a collection of music, and the interesting story here was they wanted to fly the Beatles, because that was the hottest group at the time when they started, okay? But Apple Records would not give them the copyright. And so I think blood, sweat, and tears flew into space. And of course, there were greetings from the Earth, in 55 languages from the Earth. And these greetings included, of course, Ukrainian. And if you want to hear it,
Пересилаємо привіт із нашого світу, бажаємо щастя, здоров'я і многое літа.
When the aliens find this baby, let us know